Okay, number 12. On this equation that we're given, notice that we've got the derivative on one side of the equation, and then on the right side of the equation we have two terms. Our first term is 2xy, and our second term, natural log of x times e to the x squared. The second term contains only x's, and there's no way to factor a y out, so that you could write this right side of the equation as a function of x times a function of y. And so this is not a separable ODE. If we bring this y term over to the left side, then the equation will be written in linear form. When you bring that 2xy over, you get dy dx minus 2xy is equal to the natural log of x times e to the x squared. And we want to introduce an integrating factor that is in the form e raised to the integral of the coefficient of y. It's going to be negative 2x dx. When you integrate negative 2x with respect to x, you get negative x squared. So our integrating factor is e to the negative x squared. You want to take that integrating factor and you want to multiply the entire equation through by it. E to the negative x squared. And you can distribute on the left side of the equation so that we get e to the negative x squared dy dx minus 2x e to the negative x squared times y. And on the right side of the equation, multiplying this e to the negative x squared times the e to the x squared, well, those terms will cancel out, and it'll leave you with the natural log of x. Now, once you introduce that integrating factor, these two terms that you're left with on the left side can be rewritten as a single derivative. You can have the derivative with respect to x of e to the negative x squared times y, and on the right side we just copy down the natural log of x. And then our next step is to undo this derivative by applying the inverse, the integral. So integrating both sides will undo that derivative. It'll leave you with e to the negative x squared y on the left side of the equation. And on the right side we need to integrate this natural log of x. Now this is, there's not a simple integration formula for this. And even if you try u substitution, letting u equal natural log of x, you would get du is 1 over x dx. And this doesn't work because you don't have the x in the denominator to accommodate that 1 over x. But you could try u dv substitution, where you let dv equal dx and then v is equal to x, where this will give you u times v minus v du. That's an integral, where u is natural log of x, v is x, so that gives you x natural log of x minus the integral of v that's x, du times 1 over x dx. And that's beautiful because now this integral just becomes minus the integral of 1. The x's will cancel out. And when you integrate 1, you get x. And then I'll add on my constant of integration. So I get e to the negative x squared y is equal to x natural log of x minus x plus c. And this equation can easily be solved for y by multiplying by e to the x squared on both sides of the equation. And that'll give me y is equal to e to the x squared times x natural log x minus x plus c. And that's my general solution.